Is that right? Because it's not down here.
Is it recording?
Well, but it's not down at the bottom like it usually is. And
If you click the little arrow at the bottom to show hidden icons, is it there? Okay, so just,
okay.
all right. So I'm assuming we need to start with the study guide probably. That would be the most benefit to you guys. Yes, okay. Then let's go page by page. And see what questions we have. So if we start with the first page, so 1 through 6 there, are there any questions? Any of those that you want me to work out? You guys, hopefully you've done it and you use the answer key to kind of check so you know if you're having trouble. So on the first page, is there anything we need to look at?
Speak up so she can hear you. No, I don't believe so.
Okay. Let's go to the second page then. So on this one, what do we need to look at? Sorry, you have my grunting baby to listen to.
Number 10.
Number 10. Any certain part, or do you just want to go through all of it?
All of it.
Okay. So on 10A, we are trying to find the probability of being post-term. So your denominator, we're just going to set up a fraction. Your denominator is everybody. So if we look at our grand total here, that's the 3,948,828. Okay, and then our numerator, so we're looking at 10A with probability of post-term. So if you look at your post-term column, you want your grand total of that column. So that's the 225,044. So then you just divide those two numbers and get your decimal. And I'm probably not going to take the time to actually divide those out unless you guys need me to. So B is asking for the probability that you weigh 3,000 to 3,999. So what should my denominator be in this fraction? The 3 million. It's our out of everything again. So the numerator is the weight. So this is a row, 3,000 to 3,999. So you go to the very end. I totaled up that row for you. If I didn't have the total there, you would have to add it yourself. So that's our 2,596,802. And then you would just divide those to get a decimal. So far, so good? I can't really hear if you guys are saying yes or no, so somebody yell at me if you don't understand.
They're okay on this one, I believe.
Okay. C, this one is an and. So my denominator is still out of everybody. So it's still the 3 million number for the bottom. But my numerator is the way 3,000 to 3,999 and post-term. So you are just looking for the overlap. So you go to your row 3,000 to 3,999, the column post-term, and those two meet. The number there is 160,000 354. And so then you divide those two. Okay. Part B. So 10D. This one is an OR.
Can I get those off, or do I?
I think you can make hers a big screen. You could probably tell her to use it. Here, I'm texting Cheryl.
Well, it's not her fault, but
I think you can change your layout maybe. If you go to view options, maybe change layout, see if you can do anything there. So we have a formula for OR on your formula sheet. If you go to that, it was in chapter 5, probability of E or F. It's probability of E plus probability of F minus the probability of E and F. So guys, a lot of this stuff, it seems complicated, but it's all on your formula sheet, and you're given that copy on the test. So use that to your advantage. When I ask for the OR, just write down that formula that we're going to use. So the probability of E, that's the probability of weighing 3,000 to 3,099. So we did that in part B. So you could put the fraction. Can I just go ahead and put the decimal that we got when we divided those, if I'd showed that? So on part B, when you divided those, you should have gotten 0.6576.
speak up, guys.
You with me? Okay. Then the probability of F, that's the probability post-term. We did that in part A. And when you divided those, you should have gotten 0.05699. This is why showing your work is so important, because you might have rounded that to 0.057. So as long as I have the decimal and I know how you rounded it, if your final answer is slightly different than mine, I won't count off. I just have to know where you got your numbers. So please, because there is rounding error, show me as much work as you can here. Minus the probability of E and F, we just did that in part C, and you would get 0.0406. So then if you plug those into your calculator, we get 0.6740. And again, might be slightly different due to rounding error, but as long as you showed your work, you wouldn't get counted off.
Can you move your mouse?
Okay.
Or click on the screen.
Are we okay going to part E?
Yes.
All right, so E, these are getting into the conditional probabilities. So the probability of term given you weighed less than 1,000. When there is a condition, that vertical bar, what comes after that vertical bar is the denominator. So the denominator on part E is going to be the number that weighed less than 1,000 grams. We're no longer looking at everybody, just that portion. So if I look back to my table, that's the very first row. Take a piece of paper and just cover up everything else. We know we weigh less than 1,000, so I am only looking at that row. So my total, the total for that row is 27,301. Then we still have the rest of the table covered up. We're only looking at that row. Out of those, how many were term? So 179 is your numerator. So we get 0.0066. So F, is another conditional. This time my condition is post-term. So my denominator is just the post-term. So that is a column. So basically, cover up all those other columns. Only look at that post-term portion. The total post-term was 225,044. Looking at that, we want the ones that weighed 3,000 to 3,099. So still just looking at that post-term, then those with that weight is the 160,354. And so then you divide those. Do you guys understand the conditionals?
Yes.
Okay. Part G wants to know if they are independent. If you ever don't know what something means, look at your formula sheet. So if you look under Chapter 5, the top of that page that has Chapters 5 and 6 on it, the first thing there is a complement rule. The second thing is multiplication rule for independent events. If they are independent, what that means is that the probability of one doesn't change the probability of the other. So for instance, the probability of it raining today and me having this meeting with you. The rain has no bearing on whether or not I help you study for your test. Those things are independent. Now, something that wouldn't be independent would be the probability of it raining today and the probability that they combine the field next to my house. Because if it's raining, they're not going to be in the field. So knowing that it rains changes the probability that they're in the field. Now, even if you forgot all of that, you can look at this formula sheet. And it tells you that if they are independent, then to get the probability of both things happening, you should just be able to multiply the individual probabilities. So if we look at G, we want to know if post-term and the way 3,000 to 3,099 are independent. So we have to take the probability of post-term times the probability of that weight and see if it equals the probability of both. Okay, we've already calculated all of these things, so I can use the decimals that we already found. We know the probability of both, that was part C, and that was 0.0406. The probability of being post-term, that was part A, that was 0.05699. Part B was the weight, that's 0.6576. So what we're saying is if this is independent, then this has to be true. If you multiply those things, you get 0.0375. So, are my two numbers equal? No. That means they are not independent because this equation didn't work. So that's our conclusion here, not independent. Is there anything that I missed on question 10 or the second page that you guys want me to talk about some more?
12.
Number 12, okay. So 12, we are packaging pasta sauce. So we have 12 cans. 5 of them were traditional and 7 with meat, and they didn't get labeled. So part A wants the probability that they are all traditional. So this is like an and. I want the first one and the second one and the third one. And means multiply. Or means add. So I want all of these. That's an and. I'm going to multiply the probabilities together. So when I go to pick up the first can, I want it to be traditional. How many of them are traditional? Out of how many total cans? Okay. So the probability the first one is traditional is 5 out of 12. And the second one, so that means I have to multiply. If I've already taken one traditional out, how many remain?
4.
Out of how many total cans? 11, because we already removed a can, there were only 11 left. And I want the third one to be traditional. So how many traditionals remain?
3.
Out of how many total cans?
10.
Okay, so that's part A. You just multiply those and you get your answer. Part B. I want the probability that 2 are traditional. So 2 are traditional, that means one of them has to be meat. So it might be that the first 2 are traditional and then the third one is meat. Or it might be that the second one is the meat can and the first and last were traditional. Or it could be that the first can I picked was meat and the other 2 are traditional. Now, and means multiply. What does or mean? Add. So I'm going to calculate all 3 of those and add them together. So let's go to the first one, the probability of traditional. There are 5 traditional out of 12 total cans. For the second one to be traditional, what would it be? 4 out of 11. Okay, what about the meat? How many meat cans are there?
7.
Out of 10, because I'd already taken 2 cans out. Plus, now we're going to do the second option. So the first one, traditional, that's 5 out of 12. The second one, meat, what would that be?
7 out of 11.
And the third one, traditional, would be 4 out of 10. Okay, the last option. The first one being meat, what's the probability of that?
7 out of 12.
And then traditional, 5 out of 11. And the second traditional would be 4 out of 10. So then, please, guys, on your test, make sure you're showing me this work, because if you make a mistake plugging it in your calculator, you can get partial credit if we know what you are putting in. So show me as much as you can. So then when I calculate that, you should get your 0.3182. Part C. It wants the probability that none are traditional. So if none of them are traditional, what are they? Meat. So really that's just saying what's the probability of getting 3 cans of meat sauce. So the probability of the first one?
7 out of 12.
12. Second one would be 6 out of 11. And the third would be 5 out of 10. Make sure when you put those in your calculator, you use parentheses. Do we need to look at 11 or 13 on this page?
Can you give a couple examples for 13?
Sure. Okay, so subjective probability is essentially just personal opinion. So it's the weather. You know, the weather forecast, we know it's not completely accurate. Market predictions. If you economists make all kinds of predictions about what the market's going to do, if it's going to go up, if it's going to go down, those kinds of things. Anything that is a personal opinion is subjective. Classical is what we expect to happen. So if I flip a coin 10 times, how many times would I expect to get a heads? 5, because it's a 50% chance. So if I flip it 10 times, I would expect 5 heads. If you roll a dice, there are 6 sides of the dice, so the probability of rolling a 3 would be 1 out of 6. That's classical. Now, does that guarantee that if I flip my coin 10 times, I will get 5 heads? No. Empirical probability is what we actually observe. So it might be that I flip the coin 10 times and I get a heads 8 of them. So empirical is what we actually saw. Classical is what we would expect to see. And subjective is personal opinion. Is that okay?
Yeah.
All right. Let's go to the next page. So 14 through 16, what do we need to talk about here?
Sixteen.
16. Okay. This is asking us to find the expected value of something. If you don't know what expected value is, the best option, best advice I can give you, anything you're not sure, just look at your formula sheet. So if I look under chapter 6, the very first thing that I see on my formula sheet is mean, and then it has in parentheses, expected value. So all I have to do here when I ask for the expected value, that means find the average, find the mean. And we have this formula for doing that. The mean is the sum of x times p of x. So we're going to do this like you did problem 15. We're going to make our table first. We have our x, we have our p of x, we're going to need our xp of x. You can put the x squared p of x column in there, but you really only need that if you're finding standard deviation. So we don't have to do it here. So we have to figure out what my possible x values are. X is talking about the dollar amount. Okay, so 2 things will happen here. Somebody buys a life insurance policy. They pay the life insurance company. If they live through the year, it stops right there. So if assuming my person lives, how much did she pay the company? $300. So that is the first possible x value. Okay, the other option is they pay $300 to the life insurance company. If that person dies, then the company pays them $250,000. So we have to figure out what that means. $300 is what was paid to the company. If they have to pay out, they are losing money. How would I show that x value? A negative. Now, be careful. They pay out $250,000. But they don't really lose all $250,000 because remember at the beginning, they were already paid $300. So how much money does the company lose? Excuse me. You would have to take the $250,000 and subtract off the $300 that was paid. So they're actually losing $249,700. They get to keep that $300 that was paid to them. So now to find the mean, we're going to first need our probabilities. So the $300 is if the person lives, what's the probability that they live? The second option is if they don't live. How do I find that probability? It's the complement. So 1 minus the 0.999 number. So we get 0.000456. So now, to find the mean, we have to add up the x times p of x. So my x, 300, times my p of x, 0.999544. Get my first number. Do the same thing for the second one. Negative 249,700 times 0.000456. And then what do we do for the mean? Add them together. So if you do that, you get an expected value of $186. Questions on that one?
No.
Anything else on that page?
No.
Okay. Next page. 17 through 19. What do we need to look at? Or sorry, 17 through 20. 19. Okay. This one tells us, according to a poll, 60% of U.S. women believe the minimum driving age should be 18. Okay. This one is a binomial situation. Binomial means there are only two options, yes or no. So here, either yes, they believe the minimum age should be 18, or no, they don't. Your P is the probability that they believe that thing. So what should my P be in this situation? 0.6. Q is 1 minus P, so that would be 0.4. N is the number of people we are looking at, which is 15. Okay, so before I've even read part A, I already have some information. I have my N, my P, and my Q. So part A says exactly 10 believe the minimum age should be 18. So I'm finding the probability that X equals 10. Okay, the binomial, you have two options. You can do it by hand, or you can look at the table. On the test, there will be a couple questions that ask you to do it by hand and a couple that ask you to do it from the table, just like I think on the last page there's some. Otherwise, it's kind of up to you. I recommend, if I don't tell you, use the table whenever you can. So pull out your binomial table. And I know those of you at home don't have it, so if you just look on your book, the back, Appendix A, it's on page A3, there's the binomial table. Okay. We know that my N is 15. So if you look along the left-hand side, that tells you the N values. So go to 15. And my P is 0.6. So across the top, you have to find the column where your P is 0.6. So I want the probability that exactly 10. So looking under my N equals 15, we're down, and my P is 0.6, and you get 0.1859. Okay. Did you all find that in your table? I want to know if you're having any trouble using that table. We okay with it? Okay. So part B says fewer than 5. So fewer than 5 means my X is less than 5. So that means it could be 0 or, and or means add, it could be 1 or it could be 2 or 3 or 4. So you're just going to go to your table and find all of those and add them together. On the test, please don't just give me the final answer. Write down the things you're adding together. So when I go to my 0.6, for 0 and 1, you notice those probabilities are just 0 plus. That just means it's a super small positive number, so we don't have to worry about those. So you have to add up 0.0003, 0.0016, and 0.0074. And so you get 0.0093 for your final answer. Okay. C says at least 5. So at least 5 means 5 or more. So that's 5, 6, 7, all the way up to 15. There are two options for doing that. You can either add up all those numbers from the table, or what else could we do? Yeah, we already found the probability that less than 5 from part B. So 5 or more, that's just the complement. So you just have to do 1 minus your answer from part B. So 1 minus 0.0093, which gives you 0.9907. Part D is between 7 and 12 inclusive. Inclusive means including those. So what you have to do is add up the probabilities for 7, 8, 9, 10, 11, and 12. Okay, we can get all of those from the table. So you just copy down those probabilities and add them together. So starting with the 0.1181 and moving down the column. And you get a final answer of 0.8779. What else on this page?
I think that's all on this page.
Okay. What's the black page? What do we need to talk about? 21, it does say calculate, so those are the ones you're doing by hand for the binomial.
On ones like 21, like, do we have to show any work with those?
Those are the table ones? No.
The ones
Oh, 21, sorry. The by hand ones. You might show me just a little bit. So on 21, we know the formula, and this is given on your formula sheet. You do n choose x, p to the x, 1 minus p to the n minus x. That's the formula on your formula sheet. So you might just kind of fill this in so we know what you're putting in your calculator. So on part A, you're doing 4 choose 1. Your p is 0.3 to the x, which would be 1. 1 minus p is 0.7 to the n minus x, so 4 minus 1 would be 3. So if you could show me that, then do you guys all know how to put that in your calculator? Okay. Then you should get 0.4116. So that's the amount of work I would expect. What else? I'm sure there are more questions. If I skip the problem that you want to look at, tell me that too. 23. Okay. So suppose some Christmas lights are designed. So we know probably it'll last 2 years. Each bulb is independent. Take a look at your formula sheets real quick. Part A is asking for the probability that all 100 last 2 years. So that's the first one lasts, and the second one, and the third one, and the fourth one, and so on. And I told you means multiply. So we're going to be multiplying these probabilities together. It told us they're independent, so you can just look on your formula sheet, your multiplication rule for independent events. All you have to do is multiply their individual probabilities. So the probability that the bulb lasts is 0.995. And I want all 100 of them to last. So I could either write this times itself 100 times, or the shortcut there would just be to write that to the 100th power. And that gives us 0.6058. So we have a little over 60% chance that every light will work for 2 years. Part B wants the probability that at least one burns out. Now, if we're not careful, that's a lot of work, because it's saying at least one. So one could burn out, or two, or three, all the way up to 100 of them. What's the fast way to find this? The complement. The probability that at least one burns out is the exact opposite of all of them lasting. So we just have to do 1 minus the probability that they all last. So 1 minus the 0.6058, and we get 0.3942. What else?
24.
Okay. So we know 17% of Americans bet on sports, and 48.4% of the population is male. The part A wants the probability that an adult is male and bets on professional sports. So I like to take a second and just write out what I'm finding. So I want the probability male and bets. So if you look at your formula sheet, or what we've talked about, and means multiply. So the probability of this, you just have to find the probability that they're male, multiplied with the probability that they bet. So probability of male is 0.484. The probability that they bet is 0.17. So you just multiply those two numbers together. Part B is asking for the OR. So look at your formula sheet. The probability of E or F, so the probability of male or bets, is probability of male plus the probability that they bet minus the probability of both. And that's directly off the formula sheet, the probability of E or F. So we write out our formula just to help organize our work. And now we're going to fill in the blanks. Probability of male is 0.484 plus the probability they bet is 0.17 minus what's the probability that they are a male and they bet? Right, that's what we just found in part A. What else? Anything on the study guide?
25.
Okay. So, of U.S. households, 17.9% are in the Northeast, and 5.4 earn more than $100,000 per year, and are located in the Northeast. So we want the probability that they earn more than the 100,000, given they're in the Northeast. So that given is the vertical bar if you're writing this out. Now I told you these conditional probabilities. When you're setting this up, this given part, that's your denominator. So my denominator is the ones in the Northeast, which we saw was 17.9%. So my denominator is 0.179. My numerator is out of those in the Northeast, how many earn more than $100,000? And so that set was 5.4%, so 0.054. So then we divide those. We get 0.3017. Okay. So 26. So we want the probability that you like both. So the probability, we like the first and we like the second one. Well, one means multiply, so we're going to multiply those probabilities together. There are 13 tracks, you like 5 of them. So what's the probability you like the first one? 5/13. Okay, you've already listened to the first one, and you liked it. So now, how many songs remain that you like? 4 out of how many songs remaining on the CD? So it's 5 out of 13 times 4 over 12. You get 0.1282. Part B, you dislike both. Okay, so it's pretty much the same thing. I want the probability that I dislike the first and the second. So and means multiply. So if I liked 5 of them, how many don't I like? 8. So the probability I don't like the first one is 8 out of 13. Then what's the probability I don't like the second one? 7 out of 12. So you multiply those, and we get 0.3590. Okay, part C, you have to be a little bit careful here. I want the probability I like one of them. So it might mean that I like the first one, and then I don't like the second one. Or it might mean that I don't like the first one, and then I like the second one. Or means what? Add. So what I have to do is calculate 2 different things and add them together. So the probability of liking the first one is what? 5 out of 13. If I liked the first one, what's the probability that I dislike the second one? 8 out of 12. Or, so plus, disliking the first one, what's that probability? 8 out of 13. The probability of liking the second one? 5 out of 12. So you calculate those and add them together. I know we only have a few minutes left. Is there anything that I haven't talked about that you need me to?
I think that's it.
Okay. So, couple things. If you're studying and you do have any more questions, don't hesitate to email me. I'm happy to help. Hopefully today made a big difference for you guys and kind of cleared up some of the questions you have. I'm going to have Mrs. Getty give you a review now. This is a second review just for more practice. It is optional, but if you do it, you will earn some extra credit. So I strongly recommend doing it. Not only can you get some extra credit, but it also just gives you a little more practice before your test. And just like any other homework assignment, she has the answer key in the folder, so you can come in and check it tomorrow and see if you have any questions. That sound okay to everybody? All right. Well, if you need anything, let me know. And otherwise, have a good day.
Thank you.
Thanks.
Okay.
Push the big red button, or like the hang up button. The one in the middle.
Now